But I was trying to finish making sure I had all the Excel things that we need open. Oh, I was opening up for our test. Thank
Okay,
you.
so in the book, I went to main page, and then it has like course resources, the norm, and then it has unit 1, quantitative data, unit 2, quantitative data, and I opened course resources, and down third one from the bottom, it has symbol reference page.
Ah, I see it. Awesome.
I'm like, okay, that can be an easy guide
Yeah.
for what they're trying to tell us.
That's interesting. That's interesting. Okay. Okay. It doesn't have the texture that pumpkin does. It doesn't have the same texture as pumpkin. Mm-hmm. I'm gonna make that bigger so I can find that. Very pumpkin-y.
Okay, so lesson 15 has a review for exam 2.
So when you went to resources, I'm sorry, where did you find the?
Okay, so I went to the home page of the book, and it has course resources at the top, and you click it, it opens up.
Eggnog!
Oh, so you're talking actually in the book?
Yes.
Not in
book
the. Oh,
not the course, but the book.
Okay. So I can pick any week and pull that.
Because I mean, it has like the normal applet, probability applet, it has Excel tools, exam review, the T probability on that page.
Okay, so you went to the main page. And course resources.
Yep. Third one from the bottom.
A symbol reference page. Cool.
Where do you need to go? Tell them.
Did you guys get all signed up for your classes next semester?
I did. Yeah. I can't yet. I think I have to wait until the 7th or something. I only have 58 credits.
Oh, okay.
I have an excessive amount.
What are you guys taking? I did sign up for Psych 201. Anybody else?
I signed up for that.
Who are you taking?
I can't remember. I
can't find my
book.
I have Psych 304. I don't know, 304 or something.
The research methods one.
Yes.
Oh, I've got that one too.
More of this stuff. Blech.
You think there's going to be a lot? It can't be like this.
I don't know. I'm debating printing this entire book off and keeping it and making sure I have the applets, the Excel sheets all in place so I can use them.
This is, I think, my last math class that I have to take.
It should be.
Good to get it out of the way.
I'm actually down to 8 credits next semester, and then I'm doing my internship. So
Yay.
I'm
I'm
so
taking-
excited.
I think I have an English class, my last English class I'm doing this coming semester. And then I haven't done any electives. So I'm going to do drawing. I don't know how to draw. I would love to know how to draw.
That'd be a fun
Babe?
class.
I can't find my.
That's okay. I'd love
Do some stuff up here.
Esther, for Psych 201, I have James Osborne.
Osborne, I can't find my paper. Where's all my stuff that had my schedules on it? Did you throw anything like this away that looked like? I can't. Sorry. I'm asking my husband if he threw away my stuff. I can't find it.
My husband does that a lot. He'll be like, I cleaned. I'm like, yeah, I needed those.
I can't find them now. I forgot how I'm taken.
And then I have Sociology 311. That's my other one.
311.
Yeah.
That's not in my folder. I know it's not. I actually had it over here to the side. Well, it's not here. It's not here. I think he tossed it. Oh no, here it is. Here it is. It was me. I have Dilworth for who do you have for 445? Lydia. The one that nightmare class that you're taking now? Practicum. Did we lose Lydia?
She looks frozen.
Mm-hmm.
Yeah, she looks totally froze.
So I've got Psych 302. I've got Social Work SW 260. I'm actually looking forward to that one.
I took that one last semester. That was a good class.
Was it?
Yeah, I liked that one.
Okay. I'm looking forward to that one. And then FCS 101. Because I think I'm going to do social work for my extern.
She's back.
Lydia, who did you take for practicum? Who are you taking practicum with?
Beatles.
Okay, good. I've got somebody else. I actually used that app that Jeremy was telling us about. Rate My Professor.
Yeah, I did too.
I didn't find mine on there. I found one. It's very disappointing.
For my one class, I just found ones not to take. So I didn't. The one I got, it didn't have anything on him. But the other ones, there was like 3 others that people were like, don't take the class from this person.
Yeah, and one of them said this guy's actually a great guy. Take it with him, and I think it was the practicum class. So I don't know. We'll see what I end up with.
Who are you taking it from?
I'm getting kind of burned out. Dilworth.
Dilworth. You're doing that and psych and a research class, and social work,
Yeah.
all in one semester.
Yeah, I've been doing consistently 12 credits since I started in spring.
Gee, I do 6 at a time. I tried to do 12 this semester and I ended up dropping 6 because it was just
It's hard, and I work this week. I worked 50 hours, but I don't have, bless you, but I don't have young babies at home. Babies are gone, so I don't have that to deal with.
They've always taken 12 to 13, so this coming semester with just 8, that's my last 3, besides the internship.
Wow, you're gonna
Awesome.
be a relaxing semester for you.
Psych 201 is
Right.
the one I'm not looking forward to. Is somebody taking that one? Did I hear somebody say Psych 201?
Yeah,
I
I'm
already
doing that.
took
one.
it. I'm
That's
done with
the
that
one
one.
Did you? Was that a nightmare too?
It's not a nightmare. It's just a lot of reading. We did a virtual child. We just study a lot, read a lot, flight to the
Yeah.
test.
And you have to have a person watch you do your tests.
They have the
I thought
They
online.
said it was different though. They'll watch you take
Yeah.
it.
You know, Psych 350 was not on. I had that scheduled for spring, and it's not on there anymore, and I can't drag it anywhere else. Does that mean it's going to go away?
Yeah. No, it means because they don't always offer them. Like the way my classes turned out this semester, I couldn't take one of them last semester, so I'm taking it this one. And so it's just sometimes they're on, sometimes they're not.
Some classes are just certain semesters.
Yeah.
Oh, that's interesting. So I might not be able to finish next semester then if I don't get all my.
Who's your Psych 201 teacher, Esther?
I'm going to take that in the spring.
Oh, you're not taking it yet.
No. I've got Psych 302 this
Oh,
semester coming up in winter.
See, and I'm doing a religion class, and those are more work than the 3 and 4 credit class.
There's so much work.
I had to do a PowerPoint, like a full out, presentation PowerPoint for 2 credits.
Uh-huh.
I'm getting better at it. The first time I had to do a PowerPoint presentation, I was a little freaked out. But it's a lot of work. It takes a lot of time to research and to get the right scriptures and.
Mm-hmm.
We had
Jason?
one where we had an online meeting every week with our group. Like,
Yes.
For religion?
yeah,
Oh my goodness.
every week we had a meeting, plus all the reading. Plus, I mean, and there was discussion boards, like all sorts of stuff. It was crazy.
And my first one, we had to do like improvement plan. We had to submit improvement plans. We had to apply them. We
yeah.
had to, and then talk about the benefit of the improvement plan. And I'm like, the benefit is I'm getting less sleep. Okay, thanks. But see, and I had to do another improvement plan was exercising. Nothing changed in my life. I was like, okay.
I wish it was a class where you could actually develop your own class. Do what you want. Turn it in. That's your class.
Student-led learning. Student-led.
Well, that's pretty much what we do anyway. It's pretty much we're teaching ourselves.
Yeah.
This would be a good class to have on campus, I think. I think I would really benefit more from that.
I don't know. I attempted this class once many years ago, and I still felt the same aggravation.
Really? At college?
Yeah.
Some schools have those ones where you're online, but you watch the teacher in a classroom teaching. This is one of those classes that's what it should be. You should be able
I agree.
I need more interaction. I need to be able to raise my hand and ask a question. Hey, how did you come to that? I didn't quite get that. Can you show it again?
Yeah.
I need that for this class.
Well, there are 32 questions on our quiz
Jeez.
that we
I
have to
haven't
take
done my
together.
last- I haven't even done my last quiz yet.
Either have I.
Quiz, I haven't either.
Oh, good.
Nobody-
Good. Thank you. Oh, we're in bad shape. I have to take this exam tomorrow, too.
Oh,
I'm
really?
going to do it tomorrow because
I have
tomorrow
to
night and
tomorrow.
Saturday I'm busy.
Probably just
See,
See, the
home
problem
until this
is we spend all this time on the stinking quiz together that when we get off, we're tired.
Yeah.
And it's like, I can't get back on right now and do that.
Right.
Yeah. I had 4 hours of sleep last night.
That's where I was.
See?
Just,
I keep saying I should
Well,
get
I
more
thought
sleep. My youngest is 15. I should.
I thought if we goofed around long enough, Jeremy would show up. He said he was going to be about a half hour late.
should we, anybody have questions? Should we just start it and have them catch up?
Yeah, that'd probably work.
Okay.
Yeah, so he should be coming around anytime.
This looks like it's the same questions as in the preparation assignment. Or at least it starts that way.
Yeah, it starts out with the same question, number 1. So number 1 we all picked, but number 2, given a 90% confidence interval, 45 and 105 for a mean heart rate, which of the following is the best interpretation of the confidence interval? And I put
Is
number,
somebody getting up on Hangouts call?
Is Jeremy trying to call?
let me make this bigger and see if there's something I'm supposed to do. I don't see anything. Should I maybe invite him again, just in case?
Yeah.
Yeah, that's just.
So let me do that. Let me. JEREMI.DEOSIO. I just sent it to him again, so if that was him trying to.
Oh my gosh.
Okay, did everybody open all the data files?
Yeah, I'm getting there. My computer, the more stuff I open, the slower it goes.
Badly.
Bless you.
Bless you.
My allergies are killing me lately.
It was beautiful here today. It was just gorgeous.
I was excited. We had 76 degrees. Perfect. It's like,
Yeah, that is perfect. I think we had in the 70s too. It was really nice.
Ugh.
Dodgers lost, by the way. I'm not happy about it.
Oh no.
I know.
Who are they playing against?
Houston
Houston.
Astros. Boo. And they lost at Dodger Stadium. It
Ooh,
was horrible.
Oh
that
man.
hurts.
It was the 7th game.
I don't follow any sports at all.
I'm from LA, so,
Oh, okay.
and I used to, that's like the voice of my childhood is Dodger baseball.
Oh, nice.
So it's more nostalgic for me than anything. And I've been to Dodger Stadium and have Dodger dogs. And it's
Oh, fun.
nostalgia, I think. And I think they're an awesome team, but they broke my heart yesterday.
You know what? I'm not excited about the Raiders coming to Vegas.
That's right.
They're crazy people that follow them.
That's right. You guys are getting them.
I'm like, can we get a fast train to the prison from there? Just push them in and go.
That's funny. I'm not a football fan at all.
We just don't do sports. Like, we'll go to games. When we lived in San Diego, we'd go to Padres games, and we
Yeah.
have a soccer team here we go see sometimes, but I've never, like, watched any sports on TV or anything. My dad wasn't a sports guy, so my husband's not, so we just...
Mm.
Mhm.
So you watch movies instead.
Yeah,
That's what I like.
we love our movies.
I have a brother-in-law who's a huge baseball fan. He has one son, and so my sister and brother-in-law will go to baseball games. She always ends up in the kiddie area with her son, and he's like, "I don't like it. He doesn't care."
Okay, I got all my stuff up now, finally. This is worth 30 points, he said?
My
20? 20?
Wow, I have 1, 2, 3, 4, 5, 6 Excel windows open.
Yeah.
All right.
Just a
here. Just a few. So, all right. Should we just start cruising through?
Yeah.
So I read the first one, and then we thought Jeremy was calling. So given the 90% confidence interval of 45 to 105, for the mean heart rate, which of the following is the best interpretation of the confidence interval? And seeing how it's not a chance, so C and D are wrong, and we're confident, so I would say B, we're 90% confident the true mean heart rate is between 45 and 105.
Right.
My only thing is on the video, he was showing a 95% confident interval with a standard deviation. And he was saying that meant that 95% people would be within that range.
Right.
So that's where I'm like, not confusing.
Oh, well.
So we're 90% confident that the true mean heart rate is between 45 and 105, right?
Correct.
Okay.
That's a question I got right out of, not this time, but on our last stuff.
Mm.
Okay, use the following information to answer the next 2 questions. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus for males differ from that of females. the researchers randomly select 20 females and 15 males to participate. The go, no-go stimulus required that students to respond to a particular stimulus and not to respond to another stimulus. So question 3, the researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created a QQ plot of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not?
But they are normal, aren't they?
Yeah, it says approximately, they are approximately normal.
Wouldn't it be C?
Yeah, I would say the distribution of the mean of each sample is normal since the data have been determined to be normal. How many people, this is between 20 females and 15 males.
And what was the central limit theorem? What did it say?
I know, I was just gonna, this is gonna not be good.
Let me go back. Hang on. I have the book printed.
As the sample size increases, the sample mean will look more normally distributed.
As
If
the
sample size is large, X bar will be approximately normal. If the parent population is normal, it will be normally distributed no matter what. If parent population is not normal, distribution will be approximately normal if the sample size is large enough.
Which is 30 or more, and it doesn't say how many people.
well, it said there were 20
Oh, let me see.
females and 15 males.
Okay, there it is. I don't like this new update that they did because I can only see part of a question at a time.
Yeah.
Oh, I can make it smaller, right?
I don't know.
You
Can
should.
Yeah, up in the corner, the 3 little dots under your X if you were going to close it. If you
Yeah.
click on those 3 little dots, you can zoom in or out.
It's still, I mean, now it's super tiny to read. I like the other layout better. So they're pairing the males against the females, right?
Correct.
So if the central limit theorem comes into play, would it be just 20 and 15 for each one, or is it combined since they're
35. Are there 35 or if they're comparing each other?
it wouldn't be paired though. It would have to be an independent study.
I put C originally. That's what I put.
Yeah, that's what I have.
I just wanted to ask about the distribution of the central theorem.
Okay, hold on, guys. I somehow lost my place. Okay. All right, which number are we just on? We're on.
3.
Okay.
We got a long way to go, baby.
Dang it. Okay, which one are you guys picking?
I
C.
put 3.
I put 3. I was just asking about 4 or D.
Oh, okay. Let's see.
Confidence interval stability. What is appropriate?
Because it says the distribution of sample means is normal when X bar is normally distributed or when, thanks to the central limit theorem, our sample size N is large.
So is mu known, sigma known or not known?
On this, it didn't matter.
That's not known.
Well, because they're independent samples, right? I keep going back and forth.
Yes.
Yeah, they're independent. They're not paired. So it's not A.
And it's unknown, so it's either B or C.
Yep.
No, it's either C or D.
No, because we don't know what sigma is. I think it's C.
Sigma's unknown.
What? Oh, I see what you're saying. Okay. I put
But
C.
they are independent samples.
Are you? Oh, you're looking at question 4. Or are you looking at question 3?
4.
Or
Oh, sorry. So 3, we put C. Sorry, I didn't know you moved on to 4.
yeah.
Sorry. I'm like, why
You
does
started it.
I'm like, why does mu matter? It's not there.
We're on 4, so we moved to 4.
Oh, I meant 4 as in D, as in the column. Number 3, 4 as in D. Okay.
Oh, I see. I see.
There were 4 types of confidence intervals listed, which is appropriate for the experiment. See, I didn't read that question. Well, mu is unknown. We have no idea.
Right.
And we know it's an independent study.
Yeah, since we know it's independent, wouldn't it be C?
I would say so,
'Cause we don't know the other information at all.
because they're looking for the different means using independent samples. That's what the question is. Yeah.
So you think C?
Yeah.
Yep.
All right. Number 5, a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be $3,402.08 and $4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval?
It'd have to be the 99%, wouldn't it?
Right, because that's going to give us a smaller.
Margin of error.
Yeah.
Yep. I think it's B.
Agreed. Okay, 6. A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measuring their length, and finds the sample mean to be 1,000 millimeters. The lengths are known to The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shaft. Input your answers for the margin of error, low bound and upper bound. So that's that whole big the big equation.
X bar minus T star.
Plus minus
Yeah.
X bar plus minus the standard deviation minus mu divided by something divided by the square root of n.
Do we have the sample size though? Like, do we
You
have?
have this on your internet.
Oh yeah, 4 drive shafts.
There's no intersection at Anna somewhere.
There is, but there's nothing there. We
Did
went
you
down the
drive
side
down?
roads and everything, yes. What, you don't believe me?
Remember what we're dividing n by.
It is. It's not. There's no church there.
Anybody know the rest of that formula?
When sigma or the O one, is that sigma? Is not known. It's X bar minus T star.
Divided by
S.
No, S divided by
the
N.
N.
and plus S divided by N2.
Yeah.
Right.
Ours would be Z, right? Would ours be Z? Because we have
Yeah.
we'd use the 95% Z score, right?
So 1.96.
I'm sorry, everybody talked all over everybody, and I think I have the wrong formula. Because we're saying sigma is unknown.
Mm-hmm.
I need to write a sheet out to get all these, because I just don't remember.
Okay, so that's we're going to do Z, so X bar
Right,
plus or minus, we're going to do Z star, and that's going to be the 95%, the 1.96,
yes,
times
right.
S divided by the square root of N. So is N going to be 4? 'Cause she has 4 drive shafts.
Yeah.
So,
And the sample means 1,000. And the S is 2 for the standard deviation.
right.
Well,
What unit was that in?
I
Remember?
don't know, I just have notes on my wall. I don't.
I want the notes on your wall.
That was on 1025. That was on 1025's video.
Hmm. Unknown right there. I just, for some reason, the way I wrote it out just made absolutely no sense. So it's T equals X bar minus mu divided by S divided by the square root of N.
So for the lower bound, I have 998.04, and for the upper bound, I got 1001.96.
96. And the margin of error,
I always get this wrong. I can never calculate it correctly. I don't know why.
I can't either, ever.
We lost Lydia?
looks that way.
Yeah.
Oh, I need that piece of paper that has all those silly numbers. Times S.
What did you get for the upper bound? Or the
Um,
lower bound, I mean? I did the lower bound first.
lower bound 998.04. Is that what you got?
No, I got something different. I'm gonna try this again.
What'd you get?
Oh, I got like 1400, so I gotta see what I did wrong. So it's 1000 minus 1.96 times the square root. Is it the square root of 2? No,
No, square root of 4.
4. Okay, that's what I did wrong. Minus 1.96.
What's funny is my second half, the answer is close, but not the same. 1,000 plus 0.196.
Lydia's back.
Yeah, I don't know what happened. It was very strange.
I'm still getting like 1900. I'm not getting it. I don't know why.
So you're doing 1,000 minus or plus, whichever way you want to do it.
190,
1,000 minus 1.96
right?
times
Times 2.
2 divided by the square root of 4.
Yeah, you have to get that square root of 4 in.
Okay. Oh, sorry, I did wrong. $998.04.
Yes.
Thank you.
Okay, what'd you guys get?
For the lower bound, 998.04.
998.04.
And for the upper bound, I got 1001.96.
Me too.
1001.96. Yep. Perfect.
Okay, what'd you guys have for 5? I mean 6. 6.
I didn't do it. Well, I did, but I know it's wrong. I can never figure out how to do these ones. I always do them wrong every time. So someone knows how to do them.
Let me see if that was in our
Because I have like the formulas for it, but I never get them right. So I don't know what I do wrong.
All right, I have that. My problem is that I'm not organizing my notes.
Well, that's what I'm trying to do here, because I'm definitely don't have that formula down to calculate either.
Is what is Z times? No, I don't think that's right. So is it I have an answer here for number 3 and I don't know what lesson it is, and there's a formula here. This is not helping. So it looks like an x times like x bar times z divided by the square root of the number is how you figure the margin of error. Does that ring a bell to anybody?
Yeah, I have
So
a,
margin of error is m equals z star with the sigma over n. I mean, divided by square root of n. Do we have sigma? Yeah, that'd be standard deviation, wouldn't it?
yeah.
So the z star, so the 1.96 times 2 divided by square root of n.
Which is 1.96.
Margin of error
For this.
is p star divided by s1 divided by n1 plus s2 divided by n2 is what I have for that formula. But it never comes out right for me.
I have so many margin of error. Like I have like
Yeah.
4 margin of error formulas written on my wall.
That's the problem. Is there's like, which one do we use?
Yeah.
Margin of error, z times sigma over n squared.
Right.
Yep.
That's what I thought. I just didn't know what those numbers meant.
Not I wrote down when you talked 1.96 times 2. It's not. It's sigma 1.96 divided by 2, or 1.96 times 2 divided by the square root of 4.
No, it has to be 2 times 1.96 divided by the square root of 4, right?
It's z, which is the 1.960 times
2
sigma 2 divided by
the square root of 4,
the
which
square
is
root of 4. It helps that I turn my calculator right in the middle of it.
So I get 1.96.
Yeah, that's what I got.
So that's what I'm wondering, is it just
That's still what
1.96?
I got.
Guess we'll give it a try.
And that's number 6.
See, it's one of these simple things. Ugh.
I need a massage.
Well, it makes sense because if you just do 2 divided by 4 squared, or 4, the square root of 4, the answer is 1. So 1.96 times 1 is 1.96.
Yeah.
Okay.
So if we're wrong, I'm sorry.
You get 2 tries, right?
Right.
And we're wrong together.
I lost my pencil to the ground.
Is Jeremy working tonight?
He said he was taking a test and he figured he'd be a half hour late because he was at school.
At the testing
Oh.
center, I think.
So, okay, so that's,
Hold on, I got out of this.
so we got the lower, we got the upper. Oh, we got a long way to go.
We're halfway. No, we're not even halfway there.
No.
No.
We're a third of the way there. But we're more than halfway done with the class.
That's the important part.
I know, but I'm so worried about this test. I just feel so disorganized.
Yeah.
I felt good about the last one and I didn't do as well as I wanted. So I don't know. I don't know how to gauge that anymore.
But he did make note that, you know, even though we're doing the practice, that they won't be similar, but in concept, they should be similar.
Okay, can you guys tell me number 7 and number 8 again? I didn't save them and then it closed, and sorry, there's this issue at my house right now because my youngest is in online seminary, and I sent my husband to take her to the class, and then they're like calling and texting because they can't find the class. I'm like, ah.
Okay,
Jeremy's on his way back, by the way.
7 is 998.04.
998.04.
And
8 is 1001.96.
1001 point, what was the last one?
96.
96.
Mm-hmm.
Okay, thank you.
You're welcome. Okay, number 9.
I have 38416. That one.
38146. So
38416.
to assess the accuracy of the lab scale, standard weight is known to weigh 1 gram, is repeatedly weighed a total of n times, and the mean of the weights is computed. Suppose the scale readings are normally distributed with an unknown mean and a standard deviation of 0.01. How large should n be so that a 95% confidence interval with mu has a margin of error of 0.01 0.00001. So how did you calculate that?
The sample size formula. The n equals z star times sigma divided by m squared.
Oh, that was an old one.
There it is. N equals. Like I found it.
I'm trying to make sure I write the formulas on my
Because we
sheet.
don't know what N is.
No, 'cause
Well,
we're
if we
solving
don't know
for
what
n.
M is, wait a minute. So the formula was, repeat the formula?
It's the n here.
N equals, have N equals Z.
Yep.
But if we don't know, of M over M, sorry.
We have M.
Margin of
M.
error.
Yeah.
I don't know why I wrote N under M.
The number is the M. Did you put M as being 0.0001?
Yeah.
So I came up with the same thing, 38416. Helps if I write it in the,
Wait, 38416? That's what you said, right?
38416.
Sorry.
I'm getting something different.
What are you getting?
I'm getting something different. I just erased it, but that's not what I got.
Okay, so do you know what the Z is? Did you get that right?
No, I think I turned it around. So Z is 1.96.
Correct.
Okay. And I know what the margin of error is.
So are you multiplying or adding that?
Multiplying. Right?
Well, you multiply the standard deviation.
Right, by Z. Z star.
Then you divide by,
Oh. Okay, hang on.
then you divide by the margin of error.
Right.
And then you square it after you're done.
I get 14. I'm not doing
Okay, so start again. Do 1.96
Got it. Times
times 0.01
1. Got that.
equals, then do equal,
Okay.
then divided by,
0.0001.
yes,
Square.
equals,
Oh.
just do equals, then squared.
Oh, okay.
Oh, these are new outfits for your dance? Oh, that's
I
beautiful.
just found out my calculator will transform it into unit converters from area, length,
I get
temperature.
14. I don't know what I'm doing wrong.
Here. Okay, this is how I did it. I take 1.96 times 0.01,
Right.
and I don't equal it. I divide it by 0.0001,
Squared.
and then I push equal and then squared, where it says x2, not the, no, you're doing it by x2, not the square root.
Okay. That's what I did wrong. This is where I screwed up last time. I'm going to use my phone because I think my other thing is.
How's your ankle?
Painful. I'm pain.
Don't forget your
So I
ibuprofen.
get 38416.
Mm-hmm.
Woo!
Yep, that's what you should have
Okay,
got.
thank you. Yep, I had a hard time with that one, I remember. Okay, so that's our answer, 38416.
Yes. So number 10, the mean area of several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure the random sample of apartments to test their suspicion. The appropriate null and the appropriate null and alternative hypothesis HO and HA for mu are,
Is it D?
no, it's C, because it's less than, right?
Well, C is greater. I mean, C is. You're saying you can't specify?
No, I'm saying, oh, sorry, D, it's under it.
D.
Because they're saying that it equals 1,200, but the tenants of the apartments think it's smaller than,
Right.
So that's the alternative hypothesis, so that would be it.
should be D. Because C or B is saying that mu is greater than 1,250.
But the alternative, oh, the alternative is less than though, so don't we have to do D?
Right.
Yes.
Okay.
I was just talking about the two signs, that's all.
Oh, okay.
The one was saying greater and the last one saying smaller.
Okay.
11, in a statistical test of hypothesis, we say we reject the null hypothesis with a level of significance if
Greater than.
the p-value is larger than
Mm-hmm.
the significance.
Yep. If it's
Okay.
greater than alpha, you always, no, you
No,
fail
we
to
fail
reject
to
it if it's
reject.
greater, so it has to be less than.
It's B, isn't it?
It's B, it's less than.
It has to be less than.
Yep.
Because if it was greater than, we would fail to reject.
Right.
Oh, I hate that terminology. Why can't they just speak English?
Uh-huh.
Okay, number 12. A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variance is nearly equal. Can they use a ANOVA hypothesis test to answer the question?
Mm,
Absolutely, yeah.
I thought it was 3.
Because you're getting them from different apartment buildings. So I would think it would be in ANOVA. Yep, I think it's C.
I got my papers all out of order.
Because we just did ANOVA's on Tuesday.
Right.
well, I
But there
think
were
it comes
two,
to the number. How many samples are we looking at? That's the
We're
biggest
looking
one.
at 15 times 4.
That's 60.
yeah, because some of the tests we did only had 17 or whatever,
No, I
remember?
mean, four different buildings.
Yeah.
So you normally like the paired one is 2 samples, or the 2 that are connected, or there was always 2.
Independent samples.
Yes, but there's still
But the-
2 independent. This has 4 independent. Well,
Right.
like
Four
the same
independent.
thing, 4 difference.
Yep, I think that's C.
There's another one that's not my favorite.
Medical research is working on a new treatment for certain types of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. So at an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are significantly significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. A future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has, so she rejects the null, which means that the p-value is less than alpha, right? Remember that the new treatment does not increase the mean survival time in the population of all patients. I think, let's see. So she should have computed the p-value. I forgot what a type 1 and type 2 error is now. Do you guys know?
I know, I'm looking for that right now. Oh, you know what, maybe I'll just Google it. It might be faster.
But you don't, we have to use the p-value, not the alpha number. I think that's wrong. She needed to compute the p-value.
Oh, I wanted to see that little, we had a little chart.
I was always trying to look for.
This is why this is all jacked up. This is less than 6.
A type 1 error is committed when we reject a true null hypothesis.
And a type 2 error is incorrectly retaining a false null hypothesis. I don't know what that means.
So there's that.
What's a true null hypothesis? Oh. What lesson was that in?
9.
Great, thank you. So type 1 error is undesirable. Why can't we let A equal O? This would make it impossible to commit a type 1 error. Make it impossible to reject. So that would make it impossible to reject any null hypothesis. Oh, never mind. That's not
That would be
helping.
a type 1 error, wouldn't it?
No, because alpha is not 0.
Because didn't she reject a true null hypothesis?
Okay, let's read that again. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an earlier trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. So that her thing was incorrect. Even though the sample is small, the results are statistically significant at a 0.05 significance level. Consequently, she rejects the null hypothesis.
She rejects it.
She rejects the null hypothesis. And a future study has determined that the new treatment does not increase the mean survival time in the population of all patients with that particular type of cancer. So she rejected it.
She rejected it based on the alpha number, though. Do we ever do that?
I think that's just extra wording.
I think it's just, yeah.
So it'd be she committed a type 1 error.
Yeah.
Because she rejected it and it was true.
Yeah.
Okay.
Lo, you're awesome at sharing your screen.
I love that.
It's really nifty.
I'm gonna try that next time.
Really?
You just take that. Do you take that little green arrow?
Yeah, the little green screen with the arrow. You just hit
Arrow.
Okay, so number 14. And hopefully, does Jeremy know we're still going?
Yeah, he said, I did tell him that we were gonna see him when he got
See you when you get here.
back.
You should already know we're still going.
Okay, number 14. If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
And
We need your screen again, Lo.
HA, then it'd be HA is true. No, because if you fail to reject, it's correct. Yeah, HO is false. That's okay.
Sorry. So it's saying, by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error?
Right, because you can't reject the null if alpha is 0. So if you increase alpha to 2, you have also increased your probability of committing an error.
Oh, we
Is
get
it
to
A?
Now
A.
we have to figure out the wording. Verbiage. Because here you have A is increasing the probability, and you have C of reduce the probability.
By reducing the probability of committing a type 1 error, we also reduce the probability of committing a type 2 error.
No, we increase
So
it.
we'd write a, that's not
Increase it.
even.
Would be A.
I think it's A. Do we still have 4 hours to do the exam?
Yeah.
Yes. It's a daunting amount of time.
It is.
All right. So on to, let me make sure I save that.
15.
15. A nicotine content in a cigarette of a certain brand is normally distributed. So we know it's normal with a mean and a known standard deviation of 0.17. The brand advertises that the mean nicotine content in its cigarettes, I can't believe they have a cigarette, is 1.5.
Funny.
But measurements
Important stuff.
measurements on a random sample of 100 cigarettes of this brand gave a sample mean of X bar equals 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis.
So do you want to do a test statistic?
That's what it's looking for.
Because that's X bar minus mu over standard deviation divided by the square root of n.
One more time, Miss Formula Lady.
X bar
Right.
minus mu
Right?
over S divided by
Yeah.
the
It was
square
S
root
by.
of n.
So let's figure that out here.
Do we have mu though?
X is 100. Let me
N is
read
100.
Standard deviation is 0.17. Then
So is X bar 1.53 and mu is 1.5?
the brand advertises the mean nicotine,
Yeah, it's 1.5.
1.5.
Minus 1.5 over 100, no, over 0.17 square root of 100. Okay. Plug it in.
So what did you use as, oh, X, sorry, 1.7, never mind. 1.7 is S.
Just kidding.
Did you get minus 0.01764?
1.53 minus 1.5 divided by 0.17 divided by 100 squared equals. I got 0.6476.
Whoa. Because I have 1.7647.
I have
1.7647.
I think we're all using different numbers. So we did 0.153, which is X bar, minus 1.5
Yep.
divided by,
not 0.153, it's 1.53.
1.53 minus 1.5.
Right.
And then you have to do
then
divided
on the
by with the parenthesis 1.7 divided by the square root of 100, closure parenthesis.
.17. 1.7647.
Yep.
So, at the 0.05 level of significance, conclude that you should
It just doesn't.
well, 1.7 is greater than
1.5.
1.5.
So the null hypothesis is correct.
So
we
we fail to
Fail to
no,
reject.
We reject the hypothesis.
We fail to reject it because it's higher.
No. We reject it because it's higher.
Fail to reject it. We reject it because the HA is correct. Right?
Which it's not. No, HA is correct because 1.7 is greater than 1.5. Going.
So what are they asking? Because is the evidence that the mean nicotine content is actually higher than advertised? And based on what we said, yes, it is higher.
Correct. Yes. Now we have to figure out what they're saying in math language, not English.
So if it's higher,
And that's at the 0.05 level of significance. There's a 5% chance that the null hypothesis is true.
so it means the hypothesis is not true. So we're gonna, so we can eliminate, well, we can.
We're not failing to reject it. We definitely rejected it.
Right. So are we rejecting the original hypothesis, HO, or are we rejecting the alternative hypothesis, which that is correct?
Right. We have to
reject each O.
We have to because 1.7 is greater than 1.5. It's not equal to it.
So we're rejecting HO.
Yes.
So D.
That would be D, right?
That's what I marked.
Okay.
I don't know if it's right or not, but we're moving on. So 16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure?
Can you give me something to drink with some ice?
Independent samples t-test. is it's not a paired sample, and it's not a one sample.
But is it a Z test or a T test? Ugh.
I think it's a t-test.
The independent samples T test.
That's what I think.
If it isn't one sample, there's more than one sample.
Right, more than one.
So it's not A or E. It's not the first or the last one.
Well, it could be B because that's independent because they're not paired.
They're not paired either. And it's not ANOVA because typically that's more than two.
Right. So this
So
could
I-
easily be that independent samples
Right.
because they're doing random samples of 100 for each group,
Right,
Not paired.
not paired.
not
Yeah.
paired.
It's not
And
one
that's what
sample.
confused me before, because paired, I think you have two different. You got male and female. That's a pair, you know. I learned. I was wrong.
Yeah, but it doesn't matter what order they go in. If they're paired, like a husband and wife, you want it-
Right.
Wife,
Paired
right.
to be pre-test and then the test, or husband and wife, or brother and sister.
yeah.
Okay, so cruising on to number 17. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters, so we got a pair, raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling?
Dependent. Because it matters what order they're in.
Dependent.
It's
And
dependent.
if they're in the same house,
Mm-hmm.
Before
and they
D,
can't
right?
be stepped.
But which one? Is it B or D?
I think it's D. If you select a brother so as to compare his academic achievement to a sister, you must include the sister in his study.
Yeah. Wait, oh, what? I'll get you for a second.
Okay, use the following information to answer the next 4 questions.
Oh boy, here we go.
Let me pull up the dissolved organic carbon.
I think we got that already. That's one of the ones we opened in the beginning.
Yeah.
Right, I just want to pull that one up because I got them all. Dissolved. Okay, we'll minimize the rest of these babies. Soil scientists collect random soil samples from a field and measures the dissolved organic carbon level for each sample. The measurements are recorded. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. And seeing as how we only have one list of numbers.
I want you to say that one 10 times fast, Cheryl. 10 times fast.
No. So are you going to use the one sample t-test?
Well, that's all we have is one.
Can we
Because
use
it's
the
only all one.
quantitative? What are they asking for?
Of the 4 types of confidence intervals listed below, which one is the appropriate for this situation?
Oh, I didn't even read that. I hadn't even got that far. Dang it. Why is my...
So is mu known sigma known or unknown? That's our first question.
Well, I think I messed up my file.
Hi, guys.
Hey, how are you?
Sorry. I had an anatomy test and it took me forever.
That does not sound like fun. That actually sounds like more fun than what we're doing here. But Okay,
All
so
right.
what's the question? Let me see. I use the quantitative descriptive statistics.
Well, it's asking of the 4 types of confidence intervals listed below, which is the most appropriate for the situation?
Hmm.
Is it when sigma is known, when sigma is unknown, when the confidence interval for the differences of means using an independent sample, or dependent? Now, we're not using dependent because we only have one set of numbers.
Mm-hmm. It's C then, because we know what sigma is, and we know what.
How would we know which one are we using? The one pair, one?
Well, I
sample
put it
test.
in. I put it in quantitative descriptive statistics, and I came up with a sigma.
Is it one sample t-test for means?
That's what I put it in.
Because we have that one, or I don't know what other one we'd use, except for the one sample t-test.
That's the only one I.
I
that's
put
to
in
give
the
us the
one sample
means.
t-test.
And that's to give us the means. And isn't sigma the mean?
Well, it says mean 13.193.
Sigma is the standard deviation.
Sigma is the standard deviation, which it gives us 2.
Oh, no. No, no, no. Stop.
So I thought it was C.
All right, Jeremy, you ready?
Yeah, I'm just pulling up my computer real fast and then I'll have it.
Did you guys plug it into the one test sample?
You know
I
what?
did.
I also use the quantitative descriptive statistics, and I got exactly the same thing. That first one we were using. Okay, so let's see. Get back on here.
Do we have a null hypothesis?
I think it's C.
Would the null hypothesis need to be 0?
Oh my gosh, excuse me.
Bless you.
Oh, this is where I got in trouble every other time. Ugh.
32 questions? Oh my gosh.
I know.
We're halfway there.
You're wondering why we're still here.
It's a lot. It's a lot. And then our test is due by Saturday, right?
Yeah.
Yes.
Yeah, just Saturday.
So
No problem.
excited.
Right? How'd you guys' midterms go? Did you guys do okay?
My other class doesn't have a test till the end.
Oh, nice.
There's no tests, so I didn't have midterms.
I did have one. It was okay.
Yeah.
Okay, so where are we?
It's lesson 15, right? Group meeting quiz.
Correct.
Yeah.
Here's this margin of error thing again.
My favorite.
I know, which one's the margin of error on this one sample t-test?
Is this where you take the confidence interval, the difference, and divide it by 2?
Margin of error, M equals Z star sigma divided by square root of N.
I think we don't have all that stuff.
But we have T, which would be the Z,
So
and that's 13.639. And then sigma is, did you say standard deviation of 4.326? And N is 20. Does that sound right? After
and
plugging it in? I just hope I
I'm
got all the
writing it
numbers.
down.
So.
Are we on 19 right now?
I thought so.
Okay.
So it was T.
Yep.
Which I don't know why I wrote down whatever number I wrote down, but it definitely can't be it. T is 3.301
Wait, where'd you get 3.301?
because on the table, where we put in all the information, where
On the
variable
one sample t-test?
it said T is 3.301.
Well, okay, so what is your confidence level on that?
Let me scroll up just to make sure, make it bigger so I can see. 9.95,
And what's your null hypothesis?
10.
It should be 0.
It should be 0. That
Usually 0.
fixes it.
And then not equal to.
Right, that just changes the p-value. Okay, it was 13.639.
I mean, unless I'm wrong, I thought null hypothesis would be 0 unless we were told otherwise
No, I think you're
in the equation, right?
Yes.
13.193.
Yes, that's what I have.
And this is a 95% confidence. You make that smaller.
I really hope I said that right. No one's saying anything, so I'm like, please. The null hypothesis should be 0, which means not equal to. So that means the alternate hypothesis is not equal to, and the null is equal to 0.
Awful quiet out there.
I'm falling asleep.
We're almost done now.
Okay. Awesome.
In theory.
I'm not getting that answer.
Did you get it plugged in?
No, I did, but then I'm so tired right now. I did get it plugged in, yeah. I do have it plugged in, sorry. So I've got, so for Ann, I've got 30. For the mean, I've got 617.433. Is that right?
4.3. Wait, for the what?
For the mean? Or standard error of the mean is
Standard
4.7.
deviation.
Standard deviation is 26.270.
Whoa.
What did
What
I,
is your N number?
30?
Because I only have 20 samples.
Okay,
Do you have
Let me-
extras?
probably. Let me erase this.
Jeremy, do you know where we are at now?
Oh yeah. Are we using the paired sample, the t-test, or for the means, or the other one, or that
The
quantitative?
quantitative inference procedure, one sample t-test, because there's only one set of samples.
Right.
I pulled up the wrong one. Okay, and it's 20. Mean is 13.193.
Yes, yes.
Okay. Okay. Got it.
Elevation. 6 months, yeah, it's just 6 months. That's my feeling.
She's already crapped up, so why not?
So you all know, I think 22, we're using the ANOVA. But I could be wrong.
You're doing what?
So I think we might be using an ANOVA for number 22.
No, I don't think so.
Just
Wait, are
A
we still?
lot of stuff.
No, there's only two.
Where-
You're doing New York and Los Angeles and want to know the difference.
Right, well, I'm just looking at the numbers and there's like the model, the price, the mileage.
Oh, maybe later on, not on 22 though. 22, you're just comparing the numbers for the sales between the two
Yeah.
dealers. But maybe.
What did you guys get for 19?
Oh, hang on. I'll go right back. Oh, I see. I made a big boo-boo.
Uh, 19, 13.193.
Okay, so it's just the mean is what they're asking for?
Margin of error.
Determine the margin of error, but the mean is 13.193.
Well, the number for the mean, I mean for margin of error is M equals So it'd be T star, so it's times the what is it,
191.96.
standard deviation divided by the square root of n.
Okay. Okay, so 13,193, and then lower bound is 11.168. Right?
I think it's funny though that the margin of error is the same as the mean.
That's what I'm saying. And then the upper bound is 15.217, right?
Yeah, and then the other one is 11.186 for 20.
Which one?
For
Yeah,
11,
11.168.
so 19. I wonder. I don't know. Maybe I'm doing that. I don't know.
You're a little dyslexic there, Jeremy.
I know. I know.
One.
Thinking about anatomy, and it's like, oh my gosh,
Switching gears, go.
right?
So I'm just wondering how we got the margin of error for 95% confidence interval, and it happens to be the mean number 13.193.
Well, you can have the mean number being the same as the margin of error.
Okay.
You know, let me look at something.
Unless there's a different way to figure out the
Okay.
margin of error.
Wait, because one of the questions I got wrong in our past, it said, and so the answer sheet came back. You can find the margin of error by the formula, margin of error equals the upper bound minus the lower bound divided by 2.
Okay.
Because that was a question I missed.
So 11.168.
Because the question that I missed was, for a 95% confidence interval for a true mean difference of height, find the margin of error. And her response, the response was to find the margin of error by the formula, margin of error, upper bound minus lower bound divided by 2.
I
So it's
still
my
got 13.193.
I got minus 4.049.
Because it
Are you adding
says
the two
the
together?
upper bound minus the lower bound.
Upper bound minus
Upper
the lower bound. 11.168,
Upper bound.
which is minus 4.049.
Now 15.217 minus 11.168 is 4.046 divided by 2, right?
2.025.
I'm sorry, Jeremy, I didn't hear you.
Oh, 2.025. Am I?
Where'd you find this,
Yeah.
Cheryl?
Yeah, 0.2.0.
On the test for lesson 12, let me see if it's lesson 12 or lesson 13.
Do we divide it by 2 though in this case?
On lesson 13, I missed the question that said, let me find the right quiz. Now, it's the very first question, so it's not quiz 13, so it must have been quiz 12. On quiz 12, it said, for a 95% confidence interval for the true mean difference of height, for the margin of error, round your answer to the nearest 3 decimal places. And I got it wrong. Actually, I got it right. But when I printed because I missed some others, I printed the answer sheet for this quiz on the individual feedback, and it says, you can find the margin of error by the formula, margin of error equals upper bound minus lower bound divided by 2.
So,
And that's
So
that
that
one Jeremy tried to help us with that day that he emailed us really late.
right.
So it's 2.0245.
Yeah, then you. I
Or
think
you're gonna do 3 decimal places.
So
It doesn't say
0.2
do that though.
0.25. Oh,
So 4.049. Whoa, divided by 2, sorry.
Yeah.
Whoa. Mine's, I got way big numbers. I must have hit something wrong.
2.025.
I mean,
Why does it
say
keep
divided.
adding it together? Divided by 2. 2.025.
Yep.
After all that, it took forever to type it in there. Okay. And we
So
got the little,
That's 19 then.
yes,
Yep.
Okay, good. Now I feel better about that.
me too.
And 21 was 15.217, right? Or 13 or 15. Sorry, 15. Right.
Yeah, the upper bound.
Yep.
Jeremy, Dodgers lost. I'm heartbroken.
No, I was putting my girls to bed, and then I was like on my phone, like under a blanket, because I didn't want them to see the light. So I was like
Bad.
hiding.
Bad,
Like,
bad.
please win. Oh my god.
It was bad.
I know. I was disappointed. I was happy for Houston, but I was like, oh my gosh.
I wasn't happy for Houston. I was just mad and sad. Okay, so we're on 22.
Yep. So comfortable.
A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. So we need to open used Hummers. We want to know if there is a difference in mean listing prices between Hummers for sale in Los Angeles, which is group 1, and Hummers for sale in New York, which is group 2. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. So this is
So
going to
we
be
need
an independent study, right?
It's gonna be a 2-sample t-test.
Right.
I use use a 2 sample. I use the paired sample because it gives the difference between variable 1 and variable 2.
No, because there's not the same amount of samples from each thing. They're
And
different.
you can't line them up with H1, H2, or H3.
Right.
You have to just take the price.
Because they're not paired, they're not dependent upon each other.
Right.
I keep botching it up. All right. Why won't it print? Dang it.
And the LA is group 1 or variable 1.
And that makes a difference. Remember, we got that question wrong before.
Yes. More people in LA like to buy Hummers than
Which
in
is
New
dumb
York.
because there's no snow there. What do you need a Hummer for?
Oh, cool.
It makes no sense at all.
You're not a gangsta. You don't know.
Apparently not.
You don't know what it is to be cool.
Mm-mm. No. Mean listings.
So what is the question?
So we need to look at the price and
Oh, whoops. Okay, wait. Let's answer number 22.
I was gonna say, we gotta do 22 first.
So would it
I
be
think it's C. Yes?
the difference between means and independent samples? Is that
Yeah.
We want to know if there is a difference in mean listing prices between Hummer and Los Angeles. Hummers of New York.
so? Would it be confidence interval for the difference of means using independent samples? Is that what we were doing, right?
See?
Independent. Yep.
Yes.
Okay.
Because they're not dependent on each other.
Right.
And then LA is the first variable.
And it's worth a whopping 0.5 points.
So do we all have the same t-values and all the same scores?
Oh, what do you guys have for N on variable 1?
116.
Whoa, I have too many.
And then 63. Am I wrong?
It's not calculating for me.
What was your first one again?
116.
I got 108.
Hold on, I'll
I
try
have
to.
108.
I might have
Yeah.
got.
That's what I have, 108.
Okay,
Oh, Jeremy, what do you guys have?
For which one?
108.
Sorry, I'm all lost.
For N for variable 1.
Do you have 108?
Yeah.
Ugh.
I got 108.
108.
Okay.
And then 2 is 63.
Yes.
Yes.
Oh, well, I got the first row right. Let me try the second row.
So this research would like to
Okay, I got 108 and 63.
Okay.
Right.
So what do you have for
Well, that
the
would be-
confidence level lower bound?
-4, 23.238.
Yes.
So it's -423.238, right? That's what the answer is?
Yes.
Okay, that's what I was like, got it.
And what about the upper?
5417.336.
Yeah.
Perfect. Would this be ANOVA for 25? What is the correct hypothesis test for this
Oh, I haven't
situation?
even read the question yet.
Sorry.
Jeremy came in on fire.
Right?
He's like, let's go.
So how do you think you did on your anatomy test?
Oh, it shows us our grade. I got an 80. So
Good for you.
like when you take your test, yeah. So when you take your test, you go it's like a proctor test or whatever. There's a whole bunch of students in there, and then you go turn it in, and it goes through a machine, and you walk out the door, and there's a big TV screen, and it will show you your score.
Do they broadcast
But it
it
goes
to
off your
everybody?
I number. Well, yeah, they go off your I number, so you only know like the last 4 digits of your I number.
Okay.
So yeah, it
Okay.
doesn't say your name because yeah, it would be bad because like there was some bad, like some people did really bad, but like you never know what test they're taking because there's like maybe 500 students in there taking tests at a time.
Oh my
Wow.
goodness.
Yeah, it's pretty insane. But yeah, they can be taking their math test or like their any test like that has to be done at the testing center. So yeah. But this one was 103 questions and it took me forever. So yeah.
Those anatomy tests were rough.
Oh my gosh, I know it.
I took anatomy one and I did awful.
No,
I
it's
my
tough.
major. Yeah,
Like I'm done.
that's not a good idea.
I just having a very difficult time opening. There we go, finally.
Oh, look, speaking of anatomy, we're doing a bone density.
All right, Jeremy, go. It's all you.
Oh my goodness, right?
High jump, low jump control. So, definitely ANOVA.
That's for 25?
Yeah.
Okay, that's what I thought. We just plugging in the same like the numbers again?
What's that?
Calculate the test statistics.
I must have done something wrong.
It's my turn for my computer to go all crazy
Oh,
right
I know.
now.
I forgot to empty out the variables in the other columns. Ha! Now it looks right. Well, because in the practice, it gave you a choice of A, B, C, so you can look, kind of guess if you got the right answers.
Right.
And so my numbers weren't coming even close to the numbers that were in my practice. That's
So the test statistic is F, right?
correct.
Okay, so I have 7.978.
Yes.
That's what I got. 7.978.
And then the p-value of 0.002.
Yes.
0.000. 3 zeros?
0.002. 2 zeros.
002.
002.
Yes.
I didn't get that.
The p-value, you have,
Oh, let's see.
I had to make sure I emptied out variable 4, 5, and 6 because it already
Okay,
had numbers
that's
in
fine. Yep, that's what I did wrong.
it.
There you go. 0.00189.
Right.
Okay.
So round it.
Okay, hold on, guys. I just got kicked off my test again.
Uh-oh.
It's awesome.
Okay, I gotta see the question. So we're on 25.
We're on
No.
28.
We're on 28. Oh, what'd you get for 25? ANOVA. Okay, got it.
Even, yeah, Nova.
And then the test statistic is
7.9.
7.978, right?
Correct.
Okay.
Yep.
And then 27, the p-value 0.002.
Correct.
Got it. I'm caught up now.
Expresses the conclusion of this test. Use a level of significance of A equals 0.05.
You sound really far away, Jeremy.
I know. I'm sorry. I was was kind of reading out loud and then I wasn't, but really, I don't know. I was kind of reading to myself, I guess, if you will, but. So would it be the fourth one? There is significant evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups?
I think so. That's what I marked.
Well, that's what one of the rules are of this test, right?
Yes.
So number 4, everybody cool with number 4?
Yeah.
Cool with number 4. Oh, now we got
Awesome.
one more test.
Uh,
I hope it's not
These
the
are-
window I closed.
That's okay.
Okay, wait. Which one did you do for 28 again?
The fourth one down.
Okay.
That there is significant evidence to conclude that the mean bone density of at least one of the groups is different from the bone density of at least another group.
Excuse me.
Okay, direct flight costs.
Can we get everybody back up and together?
What's up? Yeah, I think we're on 29 now, right?
Okay. Pressures of supply and demand act directly on the price of an airline ticket. As the seats available on the plane begin to fill, airlines raise the prices. I think I did this. The seats on the flight do not sell well. The airline may discount the tickets or even cancel the flight. The study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of the scheduled flight compared to a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket to London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket price for a one-way flight from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance, and then again 14 days in advance. Perform a hypothesis test to determine if there is a difference in the mean cost of the nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a
We
level.
have done.
A what?
I think we have done.
I know we
we've
did.
done this question before.
But this one's the paired isn't this one the paired?
Let's
That
see.
was 14, 13, 12. Chapter 12, lesson 12.
And we're doing it with a 90% confidence.
What is it for the paired sample?
Yeah, because it says of an airline ticket, and they want to know what it is for the same airline ticket, so it would have to be paired.
Same destination.
Same.
Right.
Oh, this is hard because they changed.
What's the first variable? Does it say?
It says, let's see, perform a hypothesis test to determine if there is a difference in the mean cost of a nonstop flight when tickets are purchased 14 days in advance compared to 90 days. So I think it would be 14 and 90.
Okay.
Yeah. So it's the dependent one.
Right. Dependent sample test. And
Oh, I couldn't copy them all. What's the deal? Oh.
So for 29, it's dependent, right? The dependent sample test?
Yeah. And the test statistic I have is 1.685.
Then 1 point, yeah, that's what I got just right now. 1.685.
Yeah.
And then give the p-value.
Which is 0.096.
6. Yep. So you guys didn't even need me. You guys
What'd
are
you guys
amazing.
put on 29?
Dependent.
29.
It's a
Dependent,
dependent.
because we're doing a paired sample t-test.
Oh, okay. Yeah, the differences. Okay.
But I have not got. What the heck? All those. Oh, 178 is where it stopped.
Guys, I keep getting kicked out of my test. This is annoying me.
Keep getting kicked out of it?
Yeah, like off the entire site.
Oh, geez.
Oh my goodness. So we just have one more question.
Yay, I'm so tired.
Oh, I think I finally got all my. Did we get 88, 88? Sorry, 88, 88, and 87?
Mm-hmm.
Our variable ones. Okay. I was
Yep,
just-
so 30.
The test statistic is 1.685.
Yep.
Yep.
Sorry, I finally got it to the p-value. Oh, we're doing 90, so we got to go 0.90. What happened with my?
Wait, we're doing.
Yeah.
Oh, hang on.
The p-value is 0.147.
No, you changed the confidence level to 90?
Yeah,
Okay, that's what I did wrong.
right?
Yeah.
So p-value?
0.96.
But my t-score is different now too.
Yeah.
So the t is 1.463.
Oh no, my t-score is the same, 1.685.
And then
What's your null hypothesis?
0.
So what changed that my t statistic changed to 1.463?
I don't know. Hit your back button, hit your undo button, see what happens.
Oh, I just got kicked out of my test, just like,
Hope you saved everything.
I did.
How do you save it?
Each question you push save when you finish answering it.
Oh, yeah. Okay.
Unbelievable.
Probably because we've been on longer than 2 hours.
What was our t statistic? I got 1.463.
I get 1.685.
That's what I got.
So what changed? It's 88, 88, 87, right?
And not equal to.
And I have not equal to. And null hypothesis is 0.
Right.
And the degrees of freedom is 86.
Yes.
And the p-value is 0.147.
No. 0. I have 0.096 for the p-value.
So what in the heck happened? I was right on the money, and then all of a sudden, and I used my back.
Your variables, maybe.
And what do you guys have for 31.685?
Yep.
Yep.
Sorry, guys. Apparently, I must have hit something or backed out of something.
And then the p-value 0.096.
Yes.
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 Okay, just make sure I'm hearing different numbers.
So which of the following best expresses the conclusion of this test?
I don't know. I can't make the numbers match.
P-value is 0.09, which is less than the level of significance.
Oh. I don't like these questions.
I think it's number 2. There's sufficient evidence to conclude that there is a difference in the mean cost of tickets. Because the p-value.
Are we doing a 2-sample test or a paired test?
Paired.
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 I just wondered if I clicked on the wrong one, but it is not.
Because
I'm
it's
not-
still the same destinations, just 14 days before and 90 days before.
What's your mean? Sorry, guys. I'm just not coming up with your same answers. What is your mean? 265.920?
No.
Mm-mm.
Or 88. There's 88, 88, and 78, correct?
No. Oh yeah, for the numbers, yeah. No, 88, 88, 87.
Yeah.
Right, 88, 88, 87.
Right.
Why aren't my, okay, I'm gonna clear out my variables and just see if maybe I copied something wrong.
Jeremy, do
Because
you
I
need,
had, and then it was
Are you-
gone.
do you need the beginning ones?
No, I'll
gonna-
come and then I can text you. I can text you guys. I'll try to work through them pretty fast because we got through 16, right? That's when I started.
Mm-hmm.
Do you want to talk to him about those while I add these in again?
Oh, it's okay, guys. I'll do them, and then if I have a question, I'll promise I won't text you too late. But
Well, she's doing something now. You want to go through them real quick?
Right, because I have to
Uh-huh.
re-add my numbers because they're not working right.
So for
no,
number
I think I'll
2.
be okay.
Oh, okay.
I don't want to keep you too long, but I had a different question while she's working on that. But like for our final, you know that final or that project we're gonna do. You guys want to determine if people live longer in like each state? So Arizona, Nevada, and then not Washington, Utah, and then Idaho. Would that be okay?
Well, that's what we were talking
So
about.
this
And,
Oh, it says like when I have to type up that thing, I have to like make give like what we're trying to do or what we're trying to determine, I guess.
well, we could use
But
an
would it be
ANOVA
okay?
test on it.
The ANOVA test.
So if we do birth date, death date, and then like who's dying, because we're gonna have more variables, so we have like 5 states or 4 states, and then the death date, because most of them are 2 samples or 1 or 2 samples, but anything over that is usually ANOVA.
Oh, okay. Because I was trying to work on that final, and I gotta type up like each question what we're trying to do, and then I'll submit it. But
We were going to work on that Tuesday, right?
yeah, no, I was just getting a head start on it,
No,
and then
it's fine. I was just.
I know.
Mm,
But yeah, I think we're
Yeah, I
planning
think
on
we
working on
decided to do each state though.
each state.
Each state, each of us have a state,
Right.
like Arizona, Utah, whatever.
But we'd probably need to get more than 10, and we'd need to do better random sampling, like pick every third Headstone or every fifth one to make it a good sample.
Right. So maybe we do 20 and then, because if we do each state, that would be 20 from Arizona, 20 from Nevada, and then Utah. Lo and Esther can do 10, 10
Well,
apiece, and that'll
I
be
can also
from.
do California because I'll be in California for Thanksgiving.
So Lo could do
So maybe we do-
California.
So then we could
So
have,
maybe we do 5 states.
yeah.
So 20, 20, 20, and then would that be okay with everybody?
And we can do an ANOVA and then show the QQ plots because we won't have 30, we'll have less than 30. So the QQ plot will show the normality or.
So if we
Okay.
don't want to have to do Q plots, we do more than 30.
No, you
I
need
think I
less than 30. For each set of numbers, it's less than 30 to show you the normal app.
Well, we could do more than 30 and not do a QQ plot.
Yeah, it's just showing that we know how to use those things, I guess.
Oh, I see. Okay.
Okay, so 20
Okay, I'm
each.
caught up, guys.
Okay.
So 30 was 1.685. The P-score was 0.096.
Let me get there.
Correct?
Yes.
Yep.
0.096, yeah.
And it's, so it's less
We have-
than, oh, that was the last question. That's,
So is there sufficient evidence to conclude? Is that what we're saying? B?
Yes. 1B. We have sufficient evidence, and then there's difference in the mean.
so that will be all of them. I think we're done.
Yeah.
Yes. I do.
Oh, does it not tell, oh, I was gonna say, does it not tell us? We missed number 5.
Compute 99% confidence interval rather than a 95% confidence interval.
We
That's
missed number
wrong.
18.
5 and 18.
5, 18. We only missed those two, 5 and 18.
That's pretty stinking great.
Yep.
So 8, what was 5? We'll go up to 5.
Well, I'm gonna go. I'll work on fixing mine later. I'm tired. So
Mm-hmm.
Okay.
thanks, you guys, and good luck.
Good
on-
night. Thanks, guys.
See ya.
Good night.
I'll make
Yeah.
that Google Doc this week, and then I'll add everybody to it so we can kind of get it going, and then we'll just work on it on Tuesday. Is that okay?
That'd be awesome.
That
Thanks,
works great.
Jamie.
Thank you.
Cheryl, I'll stay on with you for a little bit if you want.
Okay, I'll just look at these two and see if we can figure out what the deal was.
Okay.
Because, it's so funny, we did all those. I don't even remember question number 5.
So many.
It's the researcher is interested in estimating the savings account balance of customers at a large bank. This is the one, let me see. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be whatever those numbers are. Which of the following would produce a confidence level with a smaller margin of error than this 95% confidence interval? We said compute 99% confidence interval rather than 95%. Did you stop the recording there?
Oh, no, here. No, it's still recording. Hang on. Let me go there. It's one of my other screens. One of my 50 screens that I have up. But I can't find you guys. So let me see which, there you are.